Hi, everyone. I think I know most of you. You'll see me looking over here. I have a second monitor and the picture of myself, which, because I'm vain, I'm always looking at that. That's over on this monitor. So my name is Mitch Ohriner. I teach at the University of Denver. I've been attending meetings of the informatics group for quite a while, and I jumped at the opportunity to share something with you today because I figured it wouldn't be a lot of people, and I would be among friends, so I could get ornery and I could lay out my issues more clearly than I would in a more formal conference. So I want to talk today about tidy data and the Tidyverse, which sounds like a series of movies that like our students know about and we don't. So my motivation here is that we have a lot of wonderful computational music analysis packages like Music 21 and Humdrum, and these are doing really well, and they have 1,000 users or 10,000 users. Out in the real world, there are these other data science packages that have 1 million users or 10 million users that are developed by companies like Microsoft that have billions of dollars behind them. And it strikes me that to the extent that we can, we would do well to try to use some of these packages because they're maintained by huge professional staffs. I think they're easier to gain entry into than some of our what I think of as boutique packages. And a lot of music academics more generally, we have to do a lot of data science tasks anyway. We don't recognize that they're data science tasks, but they are. So I figure I would try to just sort of up the data science game in the community more generally. I just think I have too many colleagues who use Excel to do things that Excel is terrible at and takes forever to do. Okay, so that's my motivation. So what is this term tidy data? So this comes from Hadley Wickham from a journal article of 7 years ago. And the premise is that good data is tidy data, and tidy data means that the data is table-like, it is spreadsheet-like, it has rows and columns, and the columns are always variables, and the rows are always observations of variables. So here's some musical data. Right, the first here is ABC notation, which is not tidy, and the second is kern representation, which is also not tidy, and the third, maybe I should give points if you can recognize the piece. I don't expect you can, but the third is a tidy table, a tidy table of musical data, which is harder to say than I would think. And what this is showing is we have one column that's counting up the beats elapsed in the piece. We have another column that's the name class, so that assigns 0 to C and 6 to B. And another column that's the pitch class, so between these two together, we can distinguish between D sharp and E flat, et cetera, and another that describes the octave. So the issue here that I've come up with talking with colleagues a lot is I think music people kind of like this one better because you could make music from this, right? You can look at this and kind of read it. And I think there are people who can just hold a violin in their hand and play from ABC notation. And maybe if you really focused, you could do the same from kern. From this, it would be very difficult to do that, right? Because this is a data format that's optimized for the computer to do data science. And this is the data format that's optimized for a person to have some sense of what the music is about. And this is the tension between different representations. My proposal is that if we're doing computational music analysis, we should lean more towards this one, even if we're not really sure what the music is, rather than this one, because this is what the computer can work with faster than this. Okay. So the Tidyverse, might as well show this one instead. The Tidyverse is an opinionated collection of R packages. So it's written in the R language, and it's designed for data science. And it, you can tell, like, unlike humdrum, it has graphic designers who they've hired to make nice little icons for things. So it's a bunch of packages. The one that I'm going to talk about here in a few minutes is the dplyr package for data manipulation. There's also the very prominent ggplot2 package for plotting. There's a package for reading all kinds of data. This is a package for working with strings. This is a package for working with categorical data, etc. I think you might be more familiar with the Tidyverse than you might think from the ggplot package. So this is a whole bunch of plots made in ggplot2. They're gorgeous. And I think organizations like the New York Times use ggplot. A lot of the plots of information I see on the internet are very clearly have the aesthetic values of this Tidyverse. So let's return to this package dplyr. What it is it always takes as an input a data frame, which is a rectangular arrangement of data. So it's got columns and rows, and it has various verbs that manipulate that data. So there's one that will take 3 columns of data and do something in those 3 columns and make another column. So that's the mutate. There's another that will just select 1 column out of the 3. That's called select. There's one called slice that selects rows instead of columns and gets rid of the rest. There's one that I'll talk about quite a bit here in a few minutes called filter that excludes rows based on values in different columns. Where things get really powerful is the group by command. So that takes the rectangle and it makes groups out of the rectangle that have similar values in one of the columns. And all of these can be combined with each other. So there's a column to count the numbers of each group, and there's a column, this is also quite powerful, a command that's also quite powerful called summarize that reduces all the single rows to reduces the rows to a single summary. So how do you get it? If you don't use it already, which may be something I should have asked, like how many people, am I just telling people stuff they already know? Right, so you can download RStudio and you can install the package. And these are 3 fairly recent books that are quite good, that will get you up and running in R. This is a broader book about data visualization, but also it uses R. Okay, so let's go to RStudio. I could pause here if there are any questions at the moment before we start looking at some code. Okay, I guess I've paused long enough. So I'll now share a different screen. Okay, so this is RStudio. It has 4 different panes. I can show them all. So this is where you're writing code. This is the console where the code gets compiled. Down here is a place to show what files are in the current directory and some help. And here's the environment. So these are the objects in the environment. So the first thing that I wanted to work with today is our familiar billboard corpus, right? So it's a corpus of, I think my version of it, I don't know if I have all of it, my version of something like 700 songs. But I have parsed the billboard chorus into something that's tidier. So what I have here is a table of data. I can make this bigger. Okay. And recall that in tidy data, the columns are always variables and the rows are always observations of variables. And in this case, a row is a phrase. So if you're familiar with the billboard corpus, each new line is a phrase in the text file of the harmonic annotations. So each new line here is a row. So we have the song I Don't Mind by James Brown. And then we have label of a section ID. So there are 3 phrases in the intro, and then there's a bunch of phrases in the verse. We have the index of those. So this is the first phrase of the intro, second phrase, etc. We have the Roman numerals of the roots of the chords. We have a timestamp for the onset. This number of beats says how long each of these Roman numerals lasts. I worked with this quite a while ago. I honestly don't remember what M change and disrupted are. I'm sure they've seemed important at the time. And then we have the title, artist, and year. So this is the data we're working with. So let's see what we can do with it. So we could ask how much data do we have? We have a command just to get the dimensions of the data. So we're working with about 21,000 phrases, and we have 13 variables. And we can use the count command to get some tabulation of those phrases. So this will show us what kind of chronological frame we're working with. So the Billboard set that I have goes from 1958 to 1991. It seems like there's not that many songs in the 60s, and there's more songs in the 70s, and then a little bit less later in the late 80s. We can get a sense of how common the different section identifications are. So we have a whole bunch of verses, and then we have some that are much less common. Apparently only 2 of the songs in the data set end. Let's see, the names of the data, we've already kind of talked through what these are. Okay, so mutate. Mutate makes a new variable by manipulating an existing one, and select selects or discards some variables. So what I have here, I'm taking the data set, I'm sending it to mutate, and I'm making a new variable called the first chord. And the first chord comes from that roots column, but it just takes the first letter, the first character in that column. So this is the first chord. So from that, now we have a new data set that just says what harmony does this section start on. To keep going, we can select or discard observations. So here again, we're making the same new column and we're selecting the same columns, but let's just keep the first 10 of them. So now we have the first 10 rows. Filter, I think, is where things start to get powerful. So what are all the bridges that start with a 6 chord, right? So again, we can filter by the section ID is bridge. The subsection index is 1, so that means it's the first phrase of a bridge. And then the first character is 9, because 9 is the pitch class value for the 6 chord. So here, now we know that we have 32 bridges in the Billboard corpus that start on 6. Right, this is something that you know, I'm sure there are other ways of parsing this, but I don't know that there are other ways of parsing it in 4 lines of code. So summarize will reduce multiple values to a single summary. So say we want to find all of the bridges that start on the 6 chord, and we want to know the average year of those. So now we know that the average year of bridges that start on 6 chords is 1975 or so. And it turns out that that's about a year earlier than the average year of all the phrases. So it would seem, and Chris will have some comments about this when he does the chi-squared test, it would seem that bridges that start on 6 are a little bit early in the corpus. So as I said, group by makes groups of rows. So we could ask, does the average year differ for different sections? So we're taking the data and we're grouping it by section, and then we're summarizing the year. And I want to have, this is just to count up so that we can discard ones that don't have enough values. So here we get a data set with a whole bunch of columns, but what if we just filter it so that we're only looking at the sections that actually happen fairly often? So this is the average year of different sections. And something I notice here is that the pre-chorus seems a bit later than all the others. We can arrange it to highlight that. So here it seems like the pre-chorus has an average year of 1980, whereas the verse has an average year 5 years later. So that would seem to suggest that pre-chorus has come along later in the corpus. This is my grand finale since I only have one more minute. So the grand finale, how likely are different sections to end on the dominant? I can post this and we can parse it later, but just to run the code, this shows us that the pre-chorus is by far the most likely section to end on a dominant, and much more likely to end on a dominant than the chorus. So again, I'll keep sharing the screen. These are all things that there are other tools for working out, but I don't know that there are other tools that are as efficient as R. And now you can tell me if you're all just already R users and you already knew all of this. But that's all I have for now. Maybe I will stop sharing the screen.
That's very cool, Mitch. Can you? Yeah.
Okay. Oh, great.
Can we post this somewhere?
Yeah. Sure. Yeah.
Let me think about how to do that. But if you have an obvious answer to that, also just let me know and I'll link to it in the.
I'll post a PDF of the slides and then I'll figure out something to do with the code.
Cool.